All right. So later I will share you the recorded session. Okay. All right. Okay. Exercise 5.3. 5.3. I think it should be okay because basically this is just uh, add, subtract, multiply. Okay. So you just need to do this carefully and correctly. Okay. So that you can get the right answer or correct answer. So I hope that this one also should not be a problem with you. Okay. And for exercise 5.4 on the next page, this is now finding a vector represented by directed line segment AB in which initial point this time is not at the origin. Okay, so earlier, like question 5.2, okay, this is where initial point is at the origin. So this is quite straightforward in terms of a vector. Okay, the vector, to find that vector AB. Okay, but this time for exercise 5.4, initial point is now not at the origin, but it is a given point, alright, like A, B, C, D there. You are given all these initial point as well as terminal point. Okay, so again, for 5.4, this is also considered quite straightforward, alright. If you know that to find vector AB, like just now, it has to be like terminal minus initial. Okay, terminal minus initial. So you have to do this carefully. Okay, all right. For example, if let's say for A, right, I think you know if you want to find vector AB, all right. So it has to be terminal point. Okay, 7 minus the initial point. So 7 for the first component, 7 minus 3. Okay, and then for the second component, all right, 8 minus 4. And then for the third component, 3 minus 1. So you get your vector AB. So then I think BCD also should not be a problem. I think this one you know, okay, how to actually find vector AB, all right, where the initial and terminal points are given. Okay, next one is our, okay, this is now exercise 5.5. Okay, before that, there is typo. If you look at on page 189, okay, if you look at on page 189, example 5. Okay, example 5. If you can see the first part, part A, asking you for, okay, that one is actually is for magnitude, isn't it? Okay, magnitude. So B, all right, part A is asking you for magnitude of the given vector. But B, okay, asking you the unit vector of each magnitude. Actually, that B, all right, this question, the unit vector, they say find unit vector of each magnitude. Okay, this is actually can be quite confusing. Okay, this one can be quite confusing. All right, so I hope you can just you just scrap the question. All right, just scrap the question. Basically, what the question wants is actually is to find, okay, this is actually they want you to find a unit vector, all right, in the direction or in the same direction, in the direction or in the same direction. Okay, either the word is in the same direction or in the direction of this one, of this all vector f5m, and then 2m plus 3n, okay, and 2m plus n. This is what they want actually. They want you to find a unit vector in the same direction or in the direction of 5m to m plus 3n and to m plus n. Basically, this is actually the question. Okay, so the question stated that the unit vector of each magnitude you just scrap. That is actually is quite confusing. Okay, because the first part A, they already found the magnitude, ask you to find the magnitude. So when you want to find a unit vector in the direction, remember, all right, if you want to find a unit vector in the direction of, for example, 5m, then it means it will be a unit vector. It will be 5m divided by its magnitude. That's why the first part asks you to compute straight away the magnitude. Then for part B, you can straight away use that. Okay, but the question stated wrongly in the book. Okay, all right. Okay, so that is actually for that example. So let's look at exercise itself. Okay, exercise 5.5. Okay, find the unit vector. Okay, so find the unit vector. You add the word find the unit vector in the direction of. Okay, in the direction of, or you can say in the same direction. Okay, so find. So the question is find. Actually, find a unit vector. Question say like this: of 8m minus 3m plus 7n, and then n. This is the question. So you just need to add this word. Find the unit vector in the same direction. Okay. Then of those given vectors. Okay. So that's the question. Okay. Can we take a look at this one? Just one of that particular vector there. That means can you find me, or find me the unit vector, or find me a unit vector in the same direction of that vector minus 3m plus 7n? Okay, can you try that? If you haven't tried, can you try now? Maybe I'll give you like 1 minute. Then you give me the answer. Okay, try this question. Okay, I hope everyone is trying now. Okay. If anyone got the answer, please share it with us. So what's the answer? Anyone?
Madam,
Yes, okay. Cherise, what's the answer?
2 over
Okay,
set 1193
okay,
I
okay.
minus
All right,
17 over,
all right. Same, right?
yeah,
Set
and
1193.
plus
Okay. 13.
30.
Oh, 30.
Yeah.
All right, okay. Thank you. Thank you, Cherise. Okay, anybody else got any different answer for this one? Or anybody has any question or do not know how to find this unit vector in the same direction as minus 3m plus 7n? Okay, anyone got any question for this? You don't understand, or perhaps you don't get, or you got it differently, different answer than this? Anyone? Okay, so this is the correct answer, eh? This is the correct answer. So I hope you understand how to find this. So basically, you just need to find, all right? You just need to find the first step. You find your this one first. What is this minus 3m? And then what is this 7n? Then you add both. Okay, get one vector. All right, as this vector now, you find a vector which is minus 3m plus 7n. And then we said that to find a unit vector, basically what you need to do to find a unit vector in the same direction, all right, it will be that minus 3m plus 7n divided by its magnitude. So which means you need to find the magnitude, okay, of that minus 3m plus 7n. Okay, if let's say the question say you verify, in this case, the question doesn't mention you verify your answer. So if let's say there's a question says that, you find a unit vector in the same direction as this one and then verify your answer. If they say the word verify means, what do you need to do? Last time I mentioned to check or to verify means you just need to show that the length of that vector, all right, the one that you have gotten, in this case, like 2 over square root of 1193 I minus 17 over square root of 1193j plus that 30 over square root of 1193k. The magnitude of that you must show equals to 1. So this is how you verify. Okay, verify or check, okay, your answer. Okay, all right. So I have actually given you example for this, so you can refer to the example, okay, previously. Okay, so that is exercise 5.5. Okay, then let's move on to exercise 5. Okay, exercise 5.6. Okay, exercise 5.6 on page 192. Okay, all right, so this time is a dot product. Okay, this time is a dot product. So you are given two vectors. Okay, dot product. You know that for dot product, you can find this product whether it's in two-dimensional space or in three-dimensional space. So depending on what is given, for example, like this question, A and B, both actually is in three-dimensional. Okay, this is in three-dimensional space. Okay, all right. I think dot product also should not be a problem. All right. I think by now you know how to find dot product. You just need to multiply and add. Okay, with the respective component. So I think this one should be okay. Exercise 5.7. Okay, exercise 5.7 on page 196. Okay, this time you are asked to find angle. Okay, angle between the vectors and check whether vectors u and v are orthogonal. Okay, exercise 5.7. Maybe we can take a look at maybe one. Let's say we look at C. Maybe can you all try C quickly? Okay, find the angle between the vectors and check whether vectors u and v are orthogonal. Okay, orthogonal vectors. Okay, basically when you find the angle straight away you can tell. Okay, because in your formula, the formula that you are using is the formula cosine theta equals to, let's say it's a u and v. So u dot v divided by magnitude of u times magnitude of v. Okay, can you all try C? Okay, anybody got any answer? Anyone?
Madam.
Yes, okay. What's the answer
Okay,
for theta?
-5.
What do you mean by negative? Theta is, okay, find me the angle first. Find the
Point.
angle between vectors. Bashira.
Madam,
Yes.
my answer is 39.232.
Okay. Okay, 39.232. So if let's say I just round to the nearest degree, 39, Okay, Nazira. Okay, what do you get for your u dot v in the formula? What is the u dot v just now?
21.
You got 21. Okay, so that means this is not equal 0. Okay, so which means then not orthogonal. Okay, that means u and v are not orthogonal vectors. Alright, okay, thank you, Nazira. Okay, anybody else got any different answer, or you got the same answer? Or anybody do not know how to actually find this? So basically, you are given two vectors. This is the formula that you want to use. All right. You don't need to memorize because final exam is open book, so you can just find your your formula from the book. All right, and as I mentioned last time, I would suggest you just refer to the appendix. Okay, appendix in the book. There's the last page got appendix formula. Okay, for appendix for final exam, previous final exam, they have appendix, so they list all the formula. So perhaps you might want to just refer to that. Okay, quickly. Okay, so this is the theorem. All right, to find angle between two vectors. So make sure you just need to compute correctly for cosine inverse of the whole thing. So if you compute this correctly, you will get a correct answer for theta. And whether these vectors are orthogonal or not, you just look at the one that you have already computed here. Okay, so which means that when it is not equal 0, we can say that both vectors u and v are not orthogonal. So A and B also similar. So I'm sure you can actually do this. Okay, that is 5.7. Now 5.8. This is about direction angles. Okay, direction angles. That means it's alpha, beta, gamma. Okay, maybe we can take a look at just one, maybe. Just look at A perhaps. Can we look at answer for A for direction angles? So you have those formula, all right, for cosine, or in this case, this direction angle. So that means it's alpha, beta, gamma. So you have direction cosine is your cos, yeah, cos alpha equals to cos beta equals to, so that is direction cosine. So when they ask you for angles, so that means you need to solve for alpha, beta, gamma. Okay, can we take a look at the one question A? Jaya, are you there, Jaya?
Yes, madam.
Okay, can you compute this and give me the answer? Or you have done this, you already gotten the answer, and then you like to share. If not, you Jaya, okay.
I haven't. Yeah, I haven't done like this.
Okay, you
No.
try now. Okay, you try now, Jaya.
Okay. Okay, madam.
Okay, the rest of you also please try, and then we can compare the answer. All right.
Madam,
Okay. What's the answer? So what's the
for
magnitude, by the
alpha,
way? What's the magnitude for you? What do you get for magnitude for you?
64.
64. So that means your alpha between it will be cosine inverse 2 over
Sine
square root of
64.
64. All right. Okay. So what do you get for the first one?
No, it's not square root of 64.
Hmm?
I got square root of 4096.
Square root of
4096
for the what? For which one?
for
Magnitude.
magnitude. Yeah.
So that means cosine inverse. The first one, alpha will be cosine inverse 2 over square root of.
Wait a minute, miss. Wait.
Give me the magnitude for vector u.
Madam, it is square root 84, right? Not
84.
I got 84 square root, madam.
I got 84 too, madam.
84.
Yeah.
Yes.
Yes.
Okay. So square root of 84. All right. Okay, Jaya.
Magnitude is
Yeah,
77.
square root of
Okay.
84. miss.
All right. Okay. So what's the cosine inverse of 2 over square root of 84?
77.
77.
77.
Okay. What about beta?
115.
116.
115.
1 1? Is it 115 point something? What's the decimal?
116.
116, madam.
Okay, so if you round to the nearest degree, 116. Okay, gamma
84.53.
29.
29.
29.
29.
Okay.
Yes.
All right. Okay, so I hope everybody got this one. So basically, for alpha, beta, gamma, basically you have that formula. So if it's a beta, it will be cosine inverse of the second component. Second component will be -4 divided by the magnitude of vector u. In this case, is square root of 84. And then gamma is cosine inverse of the third component is 8 divided by the magnitude of the vector u, which is again square root of 84. So you do this correctly, right? Then you get your, if you round to the nearest degree, then you should get the one that's stated here. Okay. All right. So B also the same. So this one I think you can do for B. Okay. Then let's move on to exercise 5.9. 5.9. Okay. This time is now cross product.
4.
Okay. Exercise 5.9 is a cross product. Okay. For cross product, anybody got any problem to find determinant? Okay. Anybody got any problem? You do not understand how we find cross product? U cross V or A cross B? Okay. I think by now, I think everyone should know how to do this. Okay. I'm not going to look at Excel 5.9 because then 5.10, then we are going to look at this. You are going to do the same thing also. Okay. So let's look at 5.10, which is on page 202. Okay, this time is where question asks you to check whether vectors u and v are parallel or not. Okay, so this is whether vectors u and v are parallel. Okay, so let's maybe try one question. Okay, maybe try C. Can you do C? Can you?
Yes, madam.
Okay, can you see? Can you check this? Okay, remember the word is parallel. So when it comes to parallel, it has to be cross product. Okay? Parallel means cross product equal 0. Orthogonal means dot product equal 0. Okay? Okay, so this time is parallel. U and V parallel. So you need to check their cross product.
C is parallel.
Okay, do you get 0, is it?
Yes.
All right. Okay. So when your U cross V equals 0, so then you can say U and V are parallel. Okay. Anybody? Anyone got different answer, or anyone did not get 0? If you don't get 0, that means somewhere there's a mistake in calculation. Okay. C is actually parallel. Right. Anybody has problem with this? Okay, with the cross product. So if you don't get 0, that means somewhere there's a mistake, okay, in computation. So that means there's a mistake, plus minus perhaps, you know. So you should get 0. In fact, for C, if I look at the vectors itself, one vector is 1, 1, 1. Another vectors is 3, 3, 3. If you understand about vectors, they are actually parallel, because they are, if you look at 1, 1, 1 and 3, 3, 3, they are what we call multiple of each other. There's a difference in terms of a scalar multiple. U and V, actually I can write like this. U equals 3, V equals 3U, which means V equals 3 times this vector. So they are actually parallel in terms of direction. All right, in terms of direction, they are parallel. So maybe this is vector U, 1, 1, 1, 1. So there's another vector V, which is 3 times of that. 3 times of that. Okay. So they are actually parallel. Okay. But anyway, one way to tell is also using cross product. So when cross product equals 0, we can say U and V are parallel. If cross product not equal 0, we say U and V are not parallel. Okay, so that is C. Okay, A and B, if I look at just vectors like this, definitely they are not parallel. So that means you will have a cross product. You have a vector. Okay, when you do the multiplication of U and V using cross product for A and B. Okay, so you might want to try that later. Okay, let's move on to 5.11. This is 5.10. So this is 5.11. Exercise 5.11. You have 3 questions. Okay, but more or less they are the same. Question 1 is you are given 4 points, ask you to find area of a parallelogram. Question 2 ask you to find area of a triangle PQR, and question 3 also ask you to find area of a triangle. Okay, maybe I just want to look at only question 1. Okay, question 1 only. Then if you understand question 1, you can actually do the other 2 questions as well. Okay. Question 1, you have a parallelogram. All right, you want to find the area. So again, if you have your PQRS, okay, basically what you have is actually is this, right? It's a parallelogram. So let's say this is a point P, this is Q, all right, R and S. So which means that last time we said that area of a parallelogram is the same as magnitude of a cross product. Okay, magnitude of cross product. So magnitude of cross product. So in this case, all right, you have PQRS. So what you need to do is you need to establish two vectors. All right, two vectors. So you have actually, as I mentioned, many possibilities. So one possibility is you have your PQ, okay, PQ cross PS. Another possibility, it will be QR cross with QP. Okay. Another possibility, maybe vector RS cross with vector RQ. Or you can have vector SP cross SR. Or it can be, all right, you can have actually another direction. So you have actually more than one way to establish the cross product. Okay, so you have to make sure that you know which one which. The most important thing is when you establish the vector, the two vector, the initial point has to be the same, coincide. Okay, that's why you have PQ, PS, like that. QR, QP, so same initial point. RS, RQ, same initial point. Okay, so if you can find two vectors, so then the magnitude of that cross product of the two vectors will give you area of this parallelogram. Okay, all right. So can someone try this quickly, or everyone try this quickly, and then give me the answer. What's the area of this parallelogram? Maybe you
28.
just okay. You got ready?
Yes.
Okay, what do you get?
28.
Shami, you got what? 28.
28.
Okay. So you are using what? PQ?
PQ PS.
Okay, PQ cross PS. Okay, so that is area of a parallelogram. Okay, so area of a parallelogram is this. So then for question 2 and question 3, asking you to find area of a triangle. So area of a triangle, okay, for question 2 and question 3. So area of a triangle is half of the area of the parallelogram. Okay, so that means it's half of magnitude of cross product. Okay, magnitude of whatever cross product you establish. Okay, PQ cross PS or RS cross RQ, so it doesn't matter. Okay, you will get the same answer. Okay, so that is for question 2 and 3. Okay, and for exercise, that is 511, 5. Okay, 512. 512 is asking you. Okay, let's look at this. Maybe one question. Exercise. After this, we take a break. Then we will continue with the exercise chapter 5. Okay, for exercise 5.12 on page 208. This is now finding volume of the parallelopipe. Okay, so we said last time, if it's a two-dimensional, we have a parallelogram. If it's a three-dimensional, it becomes a parallelopipe. Okay, so then for volume of a parallelopipe, all right, it will be what we call using a scalar triple product. So if you have, for example, three vectors u, v, and w, okay, so we said that for scalar triple product, Okay, for scalar triple product, you have actually more than one ways to do this. Either you say u dot v cross w, or it can be v dot u cross w, or it can be w dot, all right, u cross v. Okay, so this is scalar triple product. But then for volume, all right, of a parallelepiped, will be magnitude of that scalar triple product. Okay, it will be a magnitude. And I mentioned last time, all right, even though the scalar triple product itself will give you a number. So you still need to have this magnitude symbol, because then you can also regard this as like your absolute value. So in case when you do your scalar triple product, you get negative number. So when you get negative number with this symbol absolute value, all right, you will write it as a positive number, because volume is a number. So you cannot say volume is negative something. Okay, so it has to be positive number. Okay, so maybe for exercise 5.12, maybe we can take a look at maybe the first question, maybe. First question A. Can you all try? Or anybody has done this?
The answer is 10.
Okay, the answer is
10.
volume is 10. You got 10? 10, unit cube. Okay, anybody else got any different answer? Okay. All right. Okay. Anybody got different answer for this one? For those who have done. So again, you just need to find what we call scalar triple product for the volume. So it will be your cross product first. You find your cross product first, then only you do the dot product. Okay, so you got to do cross product first, then only second step is you do your dot product. Okay, then only depending on what number you get. All right, so then if it's a negative, it still needs to be written as positive because of the magnitude. Okay, all right. Any question so far? Any question before we take a break? Any question? Okay, if not, then perhaps we'll take 5 minutes break, and after that we will continue by looking at exercise chapter 5, okay, on page 209. Okay, 5 minutes break. Okay, everyone, are you there? Are you all still there?
Yes, madam.
Okay, let's look at exercise chapter 5. Okay, so basically this exercise chapter 5, all right, this is also to sum up, okay, or to summarize everything that you have done for chapter 5. Again, question 1, I think this one should be okay. Finding a distance, all right, just use formula. Question 2 also, find vector represented by 2 points. Okay, again, this one should be okay. Question 3 asks you to express each of the vector below in standard basis. Standard basis vector means is the IJK. Okay, so the IJK representation, that means, for example, if let's say you have your B is given as sine theta and cosine theta. So they ask you to express in terms of sine theta I plus cosine theta j. This is what it means. Or you can write it in terms of like this. When it comes to sine theta, cosine theta, it's good to put your vector, your unit vector in front, so that you won't get confused with the theta. Okay, because I is a vector, it's a unit vector, so it doesn't belong to theta and it doesn't belong to sine. It's not belong to sine, so it's not angle. So to avoid that, so normally if we have like something like with the theta, sine theta, cosine theta, the unit vector, we write it in front. Okay, so this is what we call standard basis. This is what we mean by standard basis. Okay, so standard basis form. All right, so that is question 3. So that one also very straightforward. 4 also should be okay. Just arithmetic operation on vectors. All right, multiply scalar, and then you sum, you subtract. 5 also, this is also okay. Finding magnitude, compute only. Okay, magnitude of the vectors. All right, the given vector. So you still need to multiply, depending, like 2a means you multiply that a by 2 first, then only you find magnitude. Okay, so I think 5 also should be straightforward. Okay, 6 also. Okay, now 6. Okay, let's maybe we can take a look at 6. Maybe we can take a look at one question. Express each of the following vector in standard basis vector term and find the unit vector. Again, every time there's a unit vector, you will see the question will always mention unit vector in the direction, unit vector in the same direction, unit vector in the opposite direction. Okay, so basically I suppose question 6, it will be actually unit vector in the direction. Okay, in the direction, or you can say in the same direction of, okay, whatever given there, A, B, C, D. Okay, so maybe we can take a look at perhaps maybe can we look at C maybe for 6? Okay, look at 6, or maybe somebody has already computed and would like to share your answer. Anybody has done this? Okay, if not, then perhaps everybody try this question quickly. Okay, who wants to share the answer? Who wants to volunteer? So for C, you just need to find the magnitude there, the magnitude of that vector V. And then this is straightforward, because this is just a vector V only in the direction of V. So what is that answer?
Square root 101.
Okay, square root 101 is the magnitude. So that means unit vector in the direction of in this case of this V will be, so you say 101 is the magnitude, so that means it will be for C, it will be 6 over square root 101 I, and then plus 8 over square root of 101j plus k is your for the last component is 1, so 1 over 101k. So this will be the unit vector, okay, in the direction of vector V. Okay, and that V is given for C is given as 681. Okay, all right, so I think the rest you can do this. All right, you can find that. So
Madam,
yes.
can you show how to do B?
Oh, okay. B. All right. For B, okay, let's see. V equals 2 sine theta. And then this is, sorry. Yeah, 2 and then minus, right? Minus 2 cosine theta. Okay, so then first you find your magnitude. It will be 2 sine theta, the whole thing squared, plus, and then minus 2 cosine theta, the whole thing squared. So this is 4 sine square plus 4 cosine square. Alright, you got to simplify. You factorize your 4 sine square plus cosine square. You have your identity last time. This one is 1. So which means you have your square root of 4, which is 2. So that's the magnitude for V. So therefore, alright, a unit vector, okay, in the direction of vector V is, so again, it's the same thing, which is your vector V divided by the magnitude. Okay, so which means, all right, you have your 2 sine theta, 2 sine theta over magnitude is 2. This is for the I. And then plus, okay, for the second component is minus 2 cosine theta, which is, this is actually minus 2 cosine theta. So that means I will actually just put a negative after this. Okay, so then the final answer, you can just cancel your 2 here. All right. So then the final answer would be sine theta I, or you can say I in front also, and then minus j cosine theta. Okay. All right, Charis.
Yes, thank you, Madam.
Okay, welcome. Okay, any other question? All right. Okay, so that is question 6, question 6. All right, let's move on. Question 7. Question 7 is okay. I think question 7 should be okay, because then this is you are given PQR vector, and then you just need to add, subtract, and then find the magnitude. So basically this is finding magnitude of the following expression. Either it's a sum of 2 vectors, or B, you find magnitude for each P and Q first, then only you add. Okay, C also similar, you find vector minus 3P and then find its magnitude, and then separately find your magnitude for Q, then multiply by 5, then you add. Okay, so this one I think is also straightforward. You just need to do step by step, okay, accordingly. Okay, 8 also I think should not be a problem, because that is just a dot product. You are given 2 vectors U and V, and then find dot product. Similarly, 9 also the same, also dot product from the 2 given vectors, so U dot V. So that one is also straightforward. Okay, calculate the angle between the following vectors. This one also we have done just now, one of the example earlier exercises. Okay, previously you have a formula cosine theta, so I think this one also should not be a problem. You can do this. Okay, finding angle. All right. Okay, 11 also should be okay. This is actually similar to one of the example in class I gave, because you are given 11, you are given magnitude of U. Magnitude of U is given as 4. Magnitude of V vector is given as 3. Angle straight away is given. Theta is given. Alright, is 3 over 4 pi. Angle between U and V. So question asks you find U find u dot v. So basically, all right, when all this information are given, so finding u dot v, basically you cannot use component. What you need to do is to use theorem. Theorem of what? Theorem of this, right? Cosine theta is u dot v over magnitude of u times magnitude of v. So basically, angle is given, magnitude are given. So this is what you want to find. So basically, you just rearrange your equation, and then you can just plug in all the information and get the answer. So this one is also straightforward. Okay, similar to one of the example I gave in class. Okay, so this one should be okay. 12. Okay, let's look at 12 maybe. Can you all try 12? Okay, please do it now. All of you. For what values of y are the vectors yi minus 2j plus 3yk and 6i plus j plus 3yk orthogonal? Okay, again, the keyword is orthogonal. Okay, so the keyword is orthogonal. So when it is orthogonal, it is about dot product equal 0. Okay, dot product equals 0. So basically, this is asking you to find values of y. That means there'll be like some sort of like equation involved here to find y. Okay, can you all try? Okay, please try. All of you try, please. Then I'll ask people to share the answer or to give me the answer for y. Okay, anybody got answer? Anyone would like to volunteer? What's the answer for y?
The equation is 9y squared plus 6y minus 6.
Minus?
6.
Minus
Minus
6.
2. Minus 2.
Okay, minus 2. All right. Yeah, the equation will be 9y squared plus 6y minus 2 equals 0. So basically, this is your quadratic equation. So what is the y you got? So there are two possible values for y, right?
Zero point two.
You got 0.2. Another one?
Negative 0.91.
Okay, negative 0.91 or negative 9. Okay, all right. Others? Any different answer? Okay, so that means you are using straight away, perhaps that, like something like this, you cannot factorize. Okay, so then you are using your what we call quadratic formula last time. Minus b plus minus square root of b squared minus 4ac over 2a. Okay, so which means in this case, you are using minus 6 plus minus square root of 6 squared minus 4ac over 2a. Alright, so you are using your quadratic formula. Alright, so you see whether you get the same answer or not. Okay, so you will, it's possible to have this two possible answer for y. Okay, all right. I suppose everybody can get the same answer also. That is 12. Okay, any question? If not, then we move on to question 13. Okay, 13 is a direction angles again, your alpha, beta, gamma. I think this one should be okay, straightforward also. You just need to find the magnitude of that u. All right, and then only you compute your alpha, beta, gamma. So alpha will be the angle formed by vector u and positive x-axis. That is alpha. Okay, beta is the angle formed by vector u and positive y-axis. Okay, gamma is the angle formed by vector u with positive z-axis. So those are what we call direction angles. Okay, direction angles. So I think that one should be okay. 13. Okay, 14, cross product. Okay, I think this one okay, because I'm going to look at, I think 14, 15 should be okay, because then I would like to look at maybe finding, this time maybe we find area. So 14, 15, 16 should be okay. 17, we are looking at 17 now. Okay, because basically 14, 15, 16, 17, these are all cross product. Okay, so these are all cross products. So I would like to see 17 now. 17, because earlier we looked at parallelogram. So this time, can you all find area of a triangle for 17? Okay, can you all try that? What's the area of a triangle KLM for 17?
It's 1/2 square root 342.
Okay, what did you get, Shami? What's the area?
1/2.
1
1/2.
half. Okay.
Square root 342.
Square root of
342.
342. 342. This.
Yes.
Okay. Unit square. Okay. Can you tell me? You are using what vector? KL.
KL and KM.
Okay. Can you tell me what is vector KL? Your answer for vector KL first.
-1.
-1.
3 2.
Okay. What about KM? Vector KM.
3 -3 3.
3, -3, and 3. Okay, so that means then we find KL cross KM.
Product.
Okay, that means is okay IJK. All right, that means -1, 3, 2, 3 minus 3, 3. Okay, so what's your answer for the cross product?
15i
15i
9j 6k
plus 9j
plus 6k.
plus 6k.
Mm.
All right. Okay, so then only you find the area, right?
Yes.
So that means then area of a triangle KLM is half of the magnitude of KL cross KM. So that means half times square root of 15 squared plus 9 squared plus 6 squared. Okay.
Madam, I got -6k.
You got negative. Okay, hold on. Okay, so this is supposed to be this. Okay, so then just now Shami got 342. Okay, Charis, just now you mentioned what? Your minus. So that means this one.
Yeah,
Okay, let's check. Okay, but 15i plus 9j is the same, eh?
yeah, the answer all correct.
Okay, so that means so we cover. So if let's say we cover this, okay, cover the last one k. So looking at this, okay, Shami. So 3, okay, 3 minus 9, okay, 3 minus 9, so that is -6, eh? Correct, that is -6. So it should be -6. So this part is minus. Okay, so that means this is also minus, but then the answer will be the same, right? Answer will be the same, right? Cheris?
Yeah, same answer.
Okay, all right. So this is unit square. Okay, the rest of you out there, can you all follow this? Or any questions? All right. So this is for area of a triangle. Okay, so if it's an area of a parallelogram, you will be given 4 points. So if you are given 3 points, question asks you for triangle. If question gives you 4 points, okay, normally they will ask you for parallelogram. So parallelogram is just a magnitude of a cross product. So then area of a triangle is half of that. Okay, so if you have understood this 17, that means 18 also should be the same. So 18 should be okay. All right, cross product and also area of a triangle between vector u and v. So basically from the first point, ask you for cross product, and then after that just find magnitude, okay, and then multiply by half. Okay, 19. All right, this is also volume of a parallelepiped. Okay, so this one also is similar to the one that we have done in our previous exercises. I think this one also you should be okay. Use your scalar triple product. Okay, but I would like to see the last one actually. The last question, which is question 20, which is determine whether the following vectors are orthogonal, parallel, or neither. Okay. Can you all try this? Can you all try this question? Maybe I think can try all. Basically, for this question, okay, first of all, if you have this question, you are given two vectors, and then question asks you to find to determine whether vectors are orthogonal, parallel, or neither. Okay, do you think that can you have like two vectors parallel? Okay, remember parallel is about cross product. Okay, the word parallel, that means is cross product. Okay, cross product equal 0. If orthogonal, making 90 degrees, right? Orthogonal means dot product equals 0. Okay, can you have two vectors parallel at the same time orthogonal? Possible or not? Is it possible to have two vectors parallel and at the same time orthogonal? Does it make sense?
No.
No, right? Because parallel means going like this. Okay, two vectors parallel. If two vectors orthogonal means one like this, another one like this. So you cannot have these two vectors orthogonal and at the same time parallel. So not logic. Okay, it's illogical. So that means if you have such question like question 20, okay, what you need to do, you can just first find either cross product, okay, cross product, or perhaps dot product. You try that one first. So if let's say you find cross product, let's say you want to start with the cross product. So if you find cross product equals 0, straight away you don't need to show dot product. You don't need to show dot product, because if you find cross product equals 0, that means cross product equals 0, it means the two vectors are parallel. That's it. They are parallel. So that means they are not orthogonal. Okay. However, if let's say you do cross product and then suddenly it is not 0, then you need to find dot product. Okay. All right. So then only you see perhaps dot product equals 0, or it may be not equal 0 also. So if let's say cross product not equal 0, then after that dot product equals 0, then you conclude they are orthogonal. But if let's say cross product not 0, dot product not 0, then your last conclusion will be neither. Neither means it's not orthogonal nor parallel. Okay, understood? All right. Can you try quickly? You can actually start off with a dot product if you want, because that is very simple. So if let's say dot product straight away 0, then you straight away say it's orthogonal. But if it is not 0, then you follow by cross product. You have to show cross product. So maybe you might want to try this. Okay, maybe we can try all actually. ABC. See how, what did you get? Okay, I'll give you some time to try all. ABC.
A is parallel.
Oh, A, okay, you have done. Okay. So you got A,
Is
the answer
parallel.
is parallel. Okay. What about B?
Orthogonal.
Orthogonal. What about C?
Neither.
Okay, all right. So C is neither.
Neither.
Okay. So that means if the rest of you, that means A, you might want to perhaps do cross product and C. Okay, so this, it means that your cross product, this is between U and V, right? Okay, so that means U cross V, you will see that this one equals 0. Second, you will see that when U dot equal 0. Okay, this one, both not equal 0. Okay, whether you cross or you dot, both not equal 0. This is what it means. Okay, so you can try that. Okay, all of you. So again, for if you have this type of question, you can try one first. Okay, you can try do cross product first if you want, or you want to try do dot product first, up to you. Okay, maybe the easiest is dot product because then it's simple. You can just multiply and then sum. So if you do the dot product first and then you got 0, straight away you can straight away then conclude, okay, that your two vectors are orthogonal. But when you do dot product and it is not 0, that's when you have to try with cross product. Okay, all right. So I think that's all for your vectors. All right, and I think you are all ready for your final exam. Okay, for this course, for this subject. Okay, again, if you look at your textbook, your module has actually 7 review exercises in the book. So you have actually time if you want to try those questions, perhaps. Okay, you still have time to try. And those review exercises, basically, if I'm not mistaken, these are all past years. The authors actually compile some of the past year's question actually as what they call review exercises. And I think the authors also provide the last answer. So if when you try, you can check. I hope answers are all correct. There's no mistake. Okay. All right. You might want to, if let's say you got different answer, maybe you just need to double check and see, or you can ask your friend perhaps, double check with your friends as well. Okay, but so far I think because if there's a mistake, normally the authors will inform us, but nobody informed us yet, so I assume answers for review exercises are all correct. Okay, so you have actually many questions here for you to try, okay, in preparation for your final exam. Okay, anybody got any questions?
Yes,
All right,
madam.
anyone got any last minute question?
About question review exercise 1.
Okay, review exercise 1. Yeah.
Question 1C.
Okay. All right. Okay, for what values of C is the angle between the vectors equals to 60 degrees? Okay. All right. How to do this? Any idea?
I don't.
What do you
Using
get?
the
Oh, you got different answer or what?
different answer, madam. I look
Oh,
at the
you got different answer than the given answer.
yes.
Okay. So this is actually when it comes to angle, it will be about dot product, isn't it?
Yes.
Okay. So you are using for that particular question. Okay, for that particular question, this is actually is from the review exercise 1, question 1C. All right. So you are given two vectors, I, or another word, maybe I can just straight away write this. Maybe I just let one vector u here is given as that I plus 2j plus k. So that means 1, 2, and 1. This is one vector given. And then another vector v, let's say you let another vector given I plus ck. I plus ck means 1, 0, c. Okay, and then question asks you find c, all right, where theta equals 60 degrees. This is what it means, okay, by this question, right? Okay, so how do you approach to this question? You might want to use the formula, right? This one.
Yes. Cos theta equal to
Okay, so you use this. All right. Okay, so that means theta is cosine inverse of the whole thing, right? But now you are given that theta is already 60 degrees, right? So that means you are given this, and of course along the way you will have this. When you dot, you find the magnitude. So this one basically you just need to okay, what is your magnitude for v? Or what is your magnitude for U? U and V.
U is square root 6.
Okay, you got U is square root 6. Okay, so 2 squared, 1 squared, 1 squared. Okay, that is 6. Okay. V,
1 plus C square.
okay,
Square root
1 plus, okay, 1 plus C squared, isn't it?
Yes.
This one, right? Okay. And then U dot V,
1 plus C.
okay, 1 plus C, right? Okay, so basically what you want is actually not this one. You can just use straight away cosine 60, right? That
Yes.
means
1 over 2.
okay, you have your cosine 60, or maybe I can just write as like this: U dot V over magnitude of U, magnitude of V equals cosine theta. All right, then you have your U dot V is 1 plus C divided by magnitude of U is your square root of 6 times magnitude of V is your square root of 1 plus C squared equals cosine 60. So cosine 60 is what?
1 over 2.
Half.
Half it.
So basically, you are solving for 1 plus C. Okay, square root of 6 times square root of 1 plus C squared is actually, you have a choice actually. Either you want to multiply that square root of 6 into that square root 1 plus C squared, or you want to straight away multiply to half that cosine 60 also can. Okay, so basically it's actually is up to you. All right, that which means that you can do like this. Okay, this is half, right? Okay, so either you want to multiply this to this, because this is square root times square root. All right, so that means you can do like that, or you can straight away multiply, so it doesn't matter. So if let's say I just multiply square root of 6 with that square root of 1 plus C squared, so I'll be writing as under 1 square root. So I can just write as 6 plus 6C squared. I can do like that. This is half. So you just cross multiply. Okay, you cross multiply. If let's say you want to avoid having this fraction, okay, if you want to avoid having fraction, you can just multiply these two to this side. Okay, just to avoid having fraction, so that you don't have to carry along the fraction. Okay, that half. Okay, so that means you can just multiply that 2. Okay, you multiply these 2 up here, and then this one we multiply like this, like cross multiply. So which means it will be 2 plus 2C. Straight away I multiply. Then I have this. Okay. Then you get rid of the square root. This is how we get rid of the square root. We square both sides. Okay. Then on the left hand side, you just need to use your binomial expansion, a plus b squared. So it will be a squared, so which is 4, plus, okay, you can say 2ab, 2ab, 2 times 2 times 2, right? So 8c plus b squared. So 4c squared. That is on the left hand side. On the right hand side, 6 plus 6c squared. All right, and you just need to bring all terms on one side. Doesn't matter, bring left hand side to right hand side or right hand side to left hand side. Okay, so if I bring my right hand side here to the left hand side, okay, I bring my right hand side to the left hand side, so that means, all right, I will have my 4 minus 6, isn't it? So that means minus 2. Okay, 8c still 8c. Okay, and then 4c squared minus 6c squared, so that will be minus 2c squared equals 0. rearrange, write in terms of a quadratic equation properly in the form of ax squared plus bx plus c, so that you won't get confused. Okay, so that means if I rearrange, I can write it as like this, and I can actually simplify my scalar, okay, my coefficient, because I have 2, 8, 2, and at the same time, I can also write the first term as positive c squared, okay, so which means, all right, I can say that I divide each term, or I can say I divide both sides by -2. So which means that my quadratic equation now becomes c squared minus 4c and then plus 1. Do you got like this, Shami?
No, madam.
Okay, so this is the one. Then you proceed, this is actually quadratic, solving
Equation.
for, yes, for quadratic equation. So you will have two possible answers, two answers. Okay,
Okay, madam.
two answers. Remember, quadratic equation, the two answers, either two distinct real roots, okay, or two, we call it two repeated roots. Okay, and in this case, we are not dealing with complex root. So basically, solving quadratic equation, we have three possible answers. Two distinct real roots, or we say one repeated real root. Another one, actually, if in this case, we say no real root. But if we do our complex number, we will say that is actually the no real root is actually is our complex root, and they occur in conjugate pairs. Okay, okay, but until here, I think you can proceed, and see whether you can get the same answer as the one provided. Okay, so basically, this is actually solving for quadratic equation.
Okay, madam. Thank you.
All right. Okay, welcome. Okay. Anybody else got any other answer? Any other answer? Any other question? Sorry.
Madam, what about
Yes.
question 3b, what is eigenvalues?
Oh. Which one? Which one? Three.
Question
Again.
3b.
Oh, okay. Okay. This one, I think this one you can omit, because you don't learn eigenvalues in matrix. Okay, because I think this one they took the past years from maybe from the first few batches of our faculty. Okay, the students. Okay, the first few batches of student last time, we taught them about finding eigenvalues in matrix. Okay, so that's a eigenvalue section. But yours, I think this time they already scrapped that section on the eigenvalues, so you can just ignore. And moreover, for your final exam for this semester, there's no chapter 1. Last time, okay, long time ago, the first few batches, matrices is actually is the last topic. Okay, the last topic. So that's why you have a matrix in final exam. But this time, because our matrix is in the first chapter, so then our final exam don't have matrix. So if you come across any question in the review exercise on matrix, you can just ignore. Okay, just ignore them. Okay.
Okay, madam. Thank you, madam.
All right. Okay, welcome. That's why you will see like for example, like this review exercise 1, you will see that question 4, that's a application of matrices. Okay, this is application of matrices. But this time, because our matrix is in chapter 1, so we don't have chapter 1 in our final exam. Okay, the coverage is not included, all right, in our final exam. So that's why any matrix question you can ignore. Previously, our first few batches, the first topic is actually is on, if I'm not mistaken, either straight away Trigo, if I'm not mistaken. Okay, Trigo. That is the first chapter, and then our matrix is actually is our either last chapter or the second last chapter. Uh, I think if I'm not mistaken, our matrix last time is actually is chapter 4, and then 5 is vector. Vector is always the last one. Okay. So that's why you will see questions in the review exercises. If the authors took the one that earlier batches, you will see that there's a vector the matrix question inside. So you can ignore. You can just ignore. Okay. Any more question? Okay. So any questions on matrices? Okay. In the review exercises, you just ignore them. All right. Any other questions before we end the session? So this is our last session. All right. So if well, of course I don't see you, isn't it? Okay. But if you happen to be, if let's say, hopefully, I do not know when, but if let's say second semester you are coming in, or if we are going to conduct our physical classes in second sem, then you are coming back to the university, then, do drop by, or if in case you bump into me, just say hi, all right, or hello, or whatever, all right. If not, then I wish you all the best and good luck. Okay. All right. If you have no question, then we can end the session. I'm going to again share this recorded session in ULearn. Okay, under week 15. Maybe I will do that during weekend. And then I will also share with you the answer for assignment 3 as well. Okay, once I finish marking, I will share the answer in the ULearn also. I will upload. So once I do that, I will inform you again in the WhatsApp group, in the WhatsApp. I'll text you. Okay, and then also I will share you, inshallah, your 60% coursework mark. Hopefully, I can do that by this weekend so that you know your standing for the course before the final exam. So I really hope that you all can do well in the final exam. Okay, so make sure you're really prepared. Sacrifice, all right, sacrifice your time for this 1 or 2 weeks time. Okay, just sacrifice your time for final exam. After final exam over, you can really take a rest. Okay, but first sacrifice your time first. All right, so really do your revision. Okay, do exercises. Not only this subject, but other subject as well. All right, so you have other subject as well to take care of. But I think because of this paper is the first paper, so perhaps you might actually pay more attention to that. Okay, so if you have any questions, you can still ask me. All right, you can just text me. All right. If not, then I really wish you all the best and good luck. Okay. All right. Okay, everyone.
Okay, madam.
All right,
So
madam.
thank you very much for your attention
Okay,
for
madam.
one semester. All right. Sorry for any problem or technical issues or any mistakes that I've made during lesson. All right. And I wish you all the best and good luck in your final exam. And stay safe, stay healthy. All right, everyone.
Okay, madam.
Okay,
All
madam.
right. Okay. Thank you.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Okay, you're welcome.
Thank you, madam.
Okay.
I love you, madam.
Thank you.
Allah.
Okay. Welcome.
Thank you, madam.
Okay,
Saya.
Assalamualaikum.
Thank you, madam.
Okay.
Thank you, madam.
You're welcome.
Madam.